Hello, I think we're recording. Welcome to tutorial 13, where we're making 13, lucky number, where we're making Minecraft using the Python language, and we're at a critical stage. I wanted to do this about a week earlier. Sorry, I just had a very busy time, so I've not been able to do it. Which means I've also forgotten my prepared code, so I'm going to have to discover how that works kind of live. Anyway, the important thing is we want to dig through the terrain, the Perlin terrain that we've created, and have layers and have like different minerals, like types of blocks as we go down. So I've got that working in in the prepared code, which I did about a week ago. So let's have a look at this. So we just know what we're aiming at, which reminds me as I drop. People behind the scenes, like Anoush and others, have made like, I'm not sure if this was Anoush, I'll have a look in a moment, have made like animations for the axe and stuff like that. So there's loads of stuff that I want to get to and have a look at, but I've not been able to because we need to get through this key mechanic where we're digging things. Right, so I've just turned off the terrain generation. I've turned it on again. I've turned off the trees, so it's a bit faster. Let's just turn off. So I'm using G to toggle the terrain generation. So it's a bit faster as we're testing. So press F to toggle on the build mode. And if we right click here, you can see that we can now dig in the terrain, and we've got a different kind of block appearing there. I went for like a brown, but it's more red, isn't it? Anyway, if we go a little bit deeper, we've now got a new layer underneath there. And if we keep going, yes, there we go. There we go. We're going as far as we want, and I've got a little bug there. Did you see the way it was kind of like dropping? Or maybe I was dropping into the hole, which is okay. Yeah, I think we're in the hole, but the clash detection is slightly off. Anyway, we're now in our wonderful hole with a giant goose looking at us. But this is what we're after. But you can see we've got different layers, although at the moment I've just got the basic mechanic working, so we haven't got, or it's a more advanced mechanic working, but we haven't got the different materials yet. But that's easy to implement now that we've got the main system working. Right, how's that working? Well, that's working. Can I just demonstrate by, yeah, if I build a block in the middle there, middle of the air, then if I now go to mine this, I'm now using my more advanced, we're building this together, our more advanced mining system. So I right click, and what it does to give the illusion of layers is we spawn 5 cubes. So let me just highlight those with a different color. There we go. We've got 1, 2, 3, it's almost working, and 4, and then the final one is spawned underneath the place where we're mining. So let's go and do some mining down here. So if I mine this block, it will disappear. Remember, we did that by finding the vertices of the cube, which reminds me, there's a weird vertices mystery, which I discovered when preparing the code. Hopefully I'll remember to tell you about that. It should be a prize. If anyone can solve, if you can solve the mystery, the vertices mystery, then I need to give you some kind of prize. Anyway, what we were saying, so we mine this cube, and then what we do is take the vertices, we don't just lower them down, but we just send them into space somewhere else. So it looks like they've disappeared. And then we spawn these 4 cubes if it's appropriate to do so. Now, why is it appropriate to do so? Well, if we mine again, it's now appropriate to do so. Oh, almost. We've actually spawned 1, 2 on the side, and then 1 below. So we didn't need to spawn all of these all the way around to give the illusion of having cave walls or walls to where we've mined. So what we need to check is say, if there's terrain where I'm looking at now, where I've highlighted, then you don't need to spawn a cube there because there's already terrain there. So it's already filled in the gap, it's already filled in that layer. But if like here, let me just use this, if like there. Oh, can't quite get it. That reminds me, we've definitely got to improve these controls. There we go. But if like there's no terrain there, if we didn't spawn anything, then we'd just be able to look through the terrain and it would reveal that we've actually only got the one layer of terrain that we have, and the same for that side as well. So what we need to do is run a check and say, is there any terrain there? Is there any terrain there? If there isn't, then spawn some blocks in those positions. Also, we don't want to spawn a block here at any point, like if I dig down further. We also want to make sure there's no gap where we're going to spawn a cube. If we try, for instance, if we're digging, it might, and we go sidewards, it might try and spawn one of these guys into a place where we've been mining. So every time we mine, we will also want to record that location in our dictionary, our terrain dictionary, or subdic, I think we called it. We want to say there's a gap there. So when you spawn these guys, if there's terrain already there, don't spawn one. If there's a gap recorded there, don't spawn it. Okay, that's the basic system. So let's jump in. Right, so last time we took all the mining and building code from our main code. So this is exactly the same, although I've saved this now as a tutorial 13. So all my previous code is saved in tutorial 12. So I'm going to make changes to 13. And also, actually, as it stands, our mining system module, oh, wait a minute, I think I've already done this. What I could do is save what I've done in tutorial 12, where we first made this. I think I could save it as the original. Where are we? General dev. Where do we need to go? Oh yeah, clone git. Ursina tutorials, Python Minecraft. Have I saved it? Yeah, there we go. So I've got the mic. So this will be in the link to the description if you want it. So it's a good idea when you're making big changes just to save your original kind of code. So I've got mining system from tutorial 12 version. So that will be there. But now I'm working in, I'll keep that handy actually. But now I'm working in, as it was called, mining system, this module in the previous tutorial, because our main code, it will import mining system, and that's got to be called exactly what this is called, mining underscore system.py. And when we import things, we don't put the .py. But that's how this import works. It finds the file named exactly like this here. Right, so what we've got are one empty function. Oh, wait a minute. Yes, yeah, it's empty. Oh no, I thought, sorry, just before I was recording, I was looking at this and I thought the mining function was empty. Of course it's not. What have we actually got working then? Let's just hope this all works. Sorry. Well, I've already explained. I've already apologised and explained that it was about a week ago when I last looked at the code. Right, so if I try and mine with this version, yeah, there we go. We've got the gap appearing. So we have got these blocks disappearing. But now what we've got to do, as I showed you in the prepared code version, spawn a cube, one cube lower, and then just test if we need to put any walls in like we would do here. Okay, so we've got a little bit, sorry, we've got the basics of the mining working. Okay, that means I must have just changed something, sorry, since the video itself. Yeah, I think last video we just did this. We moved the vertex, the single corner, down one unit. But we don't want to do that. We want to spawn in a whole new block and then neighboring blocks to create the illusion of layers. So what I've done already, I've got hold of the vertex that is, remember all this code from last time, this looks through all the subsets, finds the vertices that are in the position where our BTE or our build tool entity is, our wireframe cube, and then this V variable will store the X, Y, and Z position of that vertex in 3D space. And it has 3 indices, therefore, index 0, index 1, and index 2. 0 stands for its X position, 1 stands for its Y position, and 2 stands for its Z position. And so V index 1 is the Y position, and I'm moving it to 99999, so really, really high in the air. So it looks like it's disappeared. If anyone can find a way to actually destroy the vertex without it making the mesh of our terrain look strange, again in the comments, let me know. I've just reminded myself we've got a vertex mystery. So let me just put move vertex high into air to give illusion of being destroyed, or being mined, if you like. Okay. The vertex mystery is to do with this code. So what I'll do is show you this mystery. In a previous version, I was using this variable, total vertices, to try to calculate the heights to work out where we need to put the block or something like that, and it didn't work. Anyway, we can use this. Total V equals 0. Every time we find a vertex that's in the right place, such that we want to make it disappear, let's say V, what's it called, count. It's called V total, sorry. Total V, my goodness, sorry. Total V plus equals 1. So we're going to add 1 to it. So we're going to count up how many vertices we destroy. Then, when we found all of the vertices, so that's going in the subsets, in all of the subsets, just before we return, then we want to say print to the console total V. That needs to be a string, else it won't print. So I'll just wrap that in parentheses with string, just so I know what it is. TV equals that space. Okay, plus that. So we concatenate this string. That means gluing together 2 strings like that. We can print that to the console. So how many vertices should we find when we destroy a cube? You should know the answer to that if you've seen the previous videos, but maybe write your answer in the comments or something, but here we go. Maybe pause the video, have a think. We did use a diagram actually last time. Let me just show you that diagram. Is it still existing? Yeah, there's our diagram. So each vertex is a corner. So the answer should be fairly obvious. But let's run the code. And all I need to do is mine one of those cubes. And let's just see how many we've got destroyed to show you this mystery. And then we need to get on actually making the system work. So here we go. 1, 2, 3. Destroyed. And you can see in the console down the bottom it says TV equals, but we can't see what it equals because tantalizingly the game is covering that up. So let me just exit the game. 36. Why did it delete 36 vertices? That's not even a multiple of 8. If it was 16, I'd be like, oh, there must be 2 cubes there somehow. But there are 36. It's like 6 times 6 or something's going on. I don't know what's happening. Anyway, if anyone can solve that, please let me know in the comments and I'll give you some kind of prize. I might not be able to send you any chocolate or anything like that, but I'll be able to, at least a shout out, but I'll try and think of something better. Maybe we'll put your picture in the game on a giant billboard or something. Anyway, there we go, there's a mystery. I'll leave that in the code. the mystery of 36 vertices. And we don't need that to print out every single time. Okay, but what we can kind of do is we can say, well, if total V equals 36, then break. So that means, because we're in this inner loop, we're going through the current subset that we're looking at. We're looking at all of the vertices in that subset. And we're only deleting one cube, or only finding the vertices of one cube. So there should only be 8 vertices, but for some reason there's 36. Anyway, once we've found those 36, we don't need to keep going around this inner loop to go through all the vertices to see if they're in that place where that cube is. Once we found 36, we know all the others must be in different positions. So we can break out of that loop. That brings us back into the main loop, but then we're saying, well, we've changed some vertices, we don't need to have a look at the other subsets, so we can generate the model, which means we can change those vertices, and then we can call return, which brings us back to the main code. Well, actually, yes. Oh, yes. What we did in the last video is in the main code here, in input, we now go to our mining system, which is called varch. And in varch, let's have a look. So back in our mining system module, if we press the right mouse button, we mine. So we go to this function, this mine, and here we are back again. So this return will take us back to where that function was called, which is in the input function. So it'll return back to here, job done. It won't look through any more subsets or vertices. So that means we've just improved, we've optimized the code a little bit there, so it's not looking through all the subsets, all the vertices to delete stuff. Right, so the next stage, back in mining, once we're here, once we've changed the location of that, all our vertices, now we need to spawn a new cube below the VTE's position, if no cube there, cube or gap there already. Next, spawn 4 cubes to create illusion of more layers if each position is neither a gap nor a place where terrain already is. Okay, so that's what we're doing, a bit of pseudocode to remind ourselves what we're doing. So we need like a little loop to go around the 4 positions, so there's only 4 to check around the VTE's position. But now, what you may be realizing as well is, if we go and have a look at our dictionary, or somewhere where it's using, so dictionary for recording whether terrain blocks exist at a location specified in the key. So we first made that dictionary when we're calling generate terrain, and here we are. So subdictionary get, and then it finds a certain position using the x and the z coordinates, and if there's an I there, it knows that piece of terrain already exists, so don't generate any more terrain there. And a similar idea now, we're saying, well, if there's already terrain here, don't spawn a pretend layer, pretend cube. But we've only got the X and the Z position. The problem is we're mining underneath. So we also need the Z position because we might have gone underneath some terrain. So that terrain has the same X and Z coordinate, it's just underneath. So the only thing that's changed is its Y position. So we need, and because we're using this subdictionary, we need all of this to be changed to have Y involved. Although there's only this, and that's all we have to kind of worry about here. But then we've also got generate Perlin, which which is fine. We don't have to worry about that. But we kind of have to go and use. We have to go and use Perlin. Sorry, where am I? The Perlin function before we use the subdictionary, because we need to know what height this position is for the top layer. So we have to do that in a different order. The Perlin function itself actually is fine, but what was I looking for? When our gravity system, when we're moving around, it is using the Perlin function. And what if we're actually underneath the terrain? We're inside the terrain. Oh, we've inside the cave, sorry, inside a mine that we've made. We did kind of cover that last time by recording. Were we recording the height? Instead of I. But it looks like we've got I back in generate the terrain. Anyway, so I must be getting mixed up with stuff that I prepared. Anyway, let's go. Why I was going quite slow there is now I'm just thinking maybe we can keep all of this intact and maybe have a separate subdictionary that has X, Y, and Z. Do we need, so we could kind of leave all of this alone, because this is just worried about generating the top layer. And the only thing we would then have to worry about is the gravity system, because it wants to refer to a new dictionary that we use. Okay, I'm thinking I might go for, I really should kind of stick to, okay, let's work this out. I'm going to put this on pause and then I'll tell you what my resulting thoughts are. Okay, I had a little think. It took about 2 minutes, something like that. I think we're going to, quite risky, we'll make a new dictionary. So, let's keep this in the mining system module. So, in the main initialization, the constructor, we also want to, we'll build this up here. We'll say dictionaries for recording positions of terrain, including gaps. Okay, so my thinking is this means we don't have to change the main module as much, and we're kind of keeping everything contained within the mining system. Okay, so this, I'm going to call it terrain dictionary, and for short let's change that to T dictionary. Okay, and TDic, there we go. And to make a dictionary, we use the curly brackets. And what I also prepared is the fact, in the prepare code, is the fact that when we're spawning our new cubes, it makes sense, and actually there's another reason to combine them, so that, like the trees, we're not just spawning loads and loads and loads of cubes, which will just slow down our program. And the way this is working is combining single entities into subsets. We want to have a list to store all of our cubes on. No, it doesn't need to be a list. Sorry, does it? No, it needs to be an entity. So that we can parent all the spawned cubes that we make to this build entity, and then we can combine it into there. Sorry, I was getting mixed up. I'm just going back to my prepared code just to see where I've done that. There we go. Oh, I have called it builds, which is bad conventionally. I think I started it as a list, or I had it in my head that it was a list. But what we've got to take is the cube model as its model. So that's important because it needs the UV coordinates for when we put a texture on it. But then we're going to make ourselves a new texture because we don't want to add the terrain's texture to it. We want to add whatever kind of mineral block type that we want. So we need a new texture. And I've got that texture prepared already. So you can download this, again, link in the description. In terrain models, I think I've put it. There we go. So we've got the block texture, and this is, can I zoom into it? There we go, the build texture. So all I did was take the ordinary block texture, or moon cube texture, I think we did, something like that. Yeah, the block texture, PNG. And I've just put monochrome noise over the top of it, so monochrome, just grey, so we can have whatever colour for our different block types, just like we're doing with the ordinary building, shine it through that texture. But we've got to have the same kind of texture map, what's that called? Yeah, texture map, because this has got the same UV points that's used by our moon cube, our main object that builds up the terrain. That's really important, else our textures won't fit properly onto our blocks. But anyway, let's go and sort that out. So in fact, I'll just copy my code. There we go. Now, I haven't got a cube model and I haven't got build text. So let's add those in here. So this build text equals, and this dot block cube model equals, and we want to use exactly the same as our main program is using. So again, copy and pasting will be good here. Have I done it right at the top? Where is it? Oh, I wasn't looking at my prepared code. There we go. Build texture PNG, and and the cube model just wants to be the same, which I think is the moon cube. that we made, I think using Blockbench, didn't we? A few tutorials ago. So there we go. Oh yes, because we're in a class, it needs to be the member variable this.cube model, or if you're using better Python conventions, self.cube model and self.buildText. But I like to use this dot. There we go. Okay, so now we can spawn our cubes using the cube model. We've got a build entity, or let's call that builds. So anything we build, we can add to this model to make sure things run correctly. So in mine, back to our pseudocode. So now we need to spawn a new cube below the BT's position. So let's just try that. So E, just for a temporary variable. So that variable will no longer exist once this function, or this, what do you call it, block of code within Python has finished. So equals an entity, and it wants to be the model, wants to be our this dot cube model, texture wants to be this dot build text, and scale will change afterwards. So we'll let it be created, and then we'll say scale times equals 0.9999 to match the ordinary terrain. Let's just see if I've got the right amount of nines there. No, I think there was one more. So the reason why we're doing that, if you can't remember, is presumably you can, because you're probably watching these tutorials closer together than I'm making them. But God, about 2 weeks ago, yeah, to be able to grab hold those vertices around the build tool entity's position, we needed to basically shrink slightly each cube, which is what we're doing here. So, in other words, just make sure I'll leave a comment actually, because that'd be confusing if you have no idea what this is. So in a year's time, when we look back at the code, we'll have no idea why we're shrinking this entity. So shrink entity, or shrink block, spawned block, so that it matches the size of ordinary terrain. And that would be really important, because if we want to mine this this block that we've just spawned, so to continue digging, this system will only work if it's the correct size. Also, that's just reminding us, when we go to improve the build system, the mine system as well. Not only are we going to look through all of the subsets of the ordinary terrain, we're going to have to look through our builds vertices as well. But there's only one builds model to look through, so we don't have to do this like double loop thing. Right. Which kind of means everything I'm doing now is going to have to be repeated. Anyway, let's just get the basics working. So the color, let's just set E dot color equals, and now can we use our new system, which we made last time, like grass, stone, netherite, or our current block type. let's go. Oh, we kind of need soil, don't we? So this block's type 0, 1, 2. I should have recorded what index these were so we can easily kind of like find them. 3, that's 4. This dot block's type. Let's just make a comment there. So when we go to improve this, what we'll have is a system where, and this is really fun, where we kind of maybe use Perlin noise again to look through all the different layers that we've got. They don't need to actually exist visually because we kind of build it as we mine to keep this really efficient and run smoothly. We can then say, like, what is this position going to be? Is it going to be like a seam of diamond, or is it going to be just soil like we're doing now? So to begin with, we'll just, and all we have to do is apply a different colour, therefore, at the moment. That's what we'll do there. I've just got a message. Let me just pause this. Welcome back, or for you, no time has passed. Yeah, just got some nice news. There's like this festival happening in our city where you can go in this like secret chamber underneath the city and then pop out somewhere else. Anyway, I've always wanted to do it, but I haven't done it. But the person messaging me is just going to get back to me with whether that is the actual case. It looks like they don't know. We'll find out. We'll find out maybe. So we've changed the colour of that. Let's just see if I'm just trying to run the program from the module. You've got to go back to the main code. That's importing that module to run that. And let's just see if we've got at least our one spawned cubed. No. So that, oh, right. Because we probably spawned it over here or something like that. We spawned it in the wrong position. Okay. Oops, just got to pause 1 second. And continuing. Right. So back in our mining system. We've changed the color, but now we want to actually position under under mined area. So e dot position equals, we could just say the BTE's position, but how to get hold of the BTE? This dot BTE, there we go. So we've made the build tool entity a member of this class, so we have access to it all the time. That's brilliant. So there we go, and then we just need to go one down. So we just need to get hold of its Y position, minus equals 1. There we go. Save it. That should be everything, right? In order to see the next layer down, as it were. Oh. Yes, okay. That's worked. And we've got kind of our soil color. Let's just go and test our system back in the mining system module. If we refer to 0, I think that was stone. Do we get stone appearing? Yes, there we go. Now, the next thing then we need to do is at, like that, kind of like check whether there's going to be a gap. And also, we should only be able to spawn if there isn't a gap, if it isn't a place where we've mined already. So let's just do that first. So we should only, yeah, I didn't read this bit. If no cube or gap there already. So if change is true, what we'll first do is record gap location in dictionary. So this dot tdic equals, and then it's square brackets, isn't it? And then I just want to go and copy the dictionary string creation code that we've already got working for generating the terrain. There we go. So this stuff. So to get it using the dictionary key, we use .get, and to assign a value at a certain key and to create the key, we use the square brackets like we do with a list. So we want to add one of those. So now we've got Y as well. And X, Y, and Z, in other words, is the BTE's position. This dot BTE dot X. Oh, that should be dot. Oh, yeah, X to X, Y to Y, and Z to Z. Let's just put all of this in brackets. It's a bit of a cheat. Can I then just do this? Just bring them all onto different lines so we can see what's going on. Hopefully that will work. If it doesn't, there's probably a better way to do that with something that I've forgotten anyway. X, Y, and Z. Oh yes, this spawned entity needs to be parented to our builds entity, so it can be combined into that. There was another reason for why I'm doing that. Anyway, parent spawned cube into builds entity. Oh, I think I know the answer. It's because, yes, when we're mining, we're using this system where we're looking for vertices. Otherwise, we'd have to have, a list of cubes that we've built, including the kind of the cave walls or the mined walls. So we'd have to keep all of those entities as separate entities that we can then delete or move around, etc. But we don't want to do that. That will slow down the program, and it'll be a different way of doing things. So what we want to do is just treat them as terrain, but we're going to have our own builds terrain so that we can apply the colours as we want to. And that's just to be clear, the terrain has the terrain texture, whereas the builds needs a different texture. because it doesn't want the grass pattern on the top and things like that. We just want a plain monochrome, this guy. We just want this texture, which we can shine different colours through. And so that's why we need this separate builds entity, because we need a separate texture for blocks that we're mining to. Okay. Parent, okay, that's what we're doing. So we get hold of E, your parent equals this dot builds. And remember, just have a look at this dot builds near the top. Oh, that's what I was looking at last time. We have left build and mine, but we have now got build and mine, so I need to delete those. Strangely, it was still working. What was I just showing ourselves? Yes, here we are. This dot builds is an entity that crucially has this build texture on. It has the same cube model as the moon cube, as our main terrain. Okay, and tdict is the terrain dictionary, or build terrain dictionary, is recording all these positions instead of using the subterranean dictionary. But that's actually something that we want to do. We want to go and use this in the main module. Once we've built a piece of terrain, we also want to record its position. So record position of this terrain in both the sub-dictionary and the mining systems dictionary. There we go. And that belongs to Varch. That was the name of our mining system. So we can't just write this .tdictionary, because this refers to a class that you're currently in. And in our main module, our PyCraft tutorial 13, as it stands, we need to first get hold of our mining system, which is called Varch, which we imported. Somewhere here we are. No. Near the top, presumably. There we are. Varch equals mining system. There we go. That's where we create our mining system, or initialize it. And so if we want to get hold of any of its variables or functions, we have to write varch dot, and now we can get hold of its dictionary. Really, it should have its own function where we just say varch dot record location, and then just pass in x, y, z. But we're not going to because this is quicker. But you can see this, this shouldn't be here. All of this kind of information should be inside the mining module. So there's something we can improve way in the future if we need to. Right, so it can't apply Y yet because Y doesn't exist. The Perlin noise needs to be applied first. So actually this needs to come afterwards. There we go. And actually, shall I then place that there as well? Oh, I've done this wrong, haven't I? I'm probably going to have to keep this on one line now. Like that. Equals And what we're going to do is record the height. So equals y. So this stuff is the key in our dictionary, and we're going to kind of repeat the height so that we can kind of calculate where our terrain is later on. Right, so I've made a mistake there back in the mining. Yeah, this doesn't kind of make sense, does it? I have to build the key this way. Can I do that in square brackets? That's the question. Does it act like like parentheses? It seems to be okay, but this may all go wrong. But we'll find out. If that doesn't work, maybe I don't know. Okay, so record gap location. And then we need to go, equals gap. There we go. So that's how we've recorded a gap. And then, hopefully that's all okay, because then we can say, once we've spawned a cube here, we need to record the height, which is going to be e.y. Yeah, because we move the spawned cube 1 unit down, so that's the height that we want to record in our dictionary. Okay, let's just see if I can get away with doing these on separate lines with square brackets. I've only done that with parentheses before. And the sun's coming out. Good news, because I've got washing out. Press G, so we're not generating a terrain, it's running a bit faster. And mine. Okay. To begin with, it looks like something is working. Okay, so at the moment we're just spawning that one. What happens if I try to spawn? Yeah, if I try to mine stuff there, it's not being mined because we're only looking over the main terrain. We're not looking over the built terrain. But I've got something happening. Assertion failed. Something is empty. So something is happening with my moon cube when I was mining. So it's not causing a problem. There was nothing going wrong as far as I could see. But maybe this line here, 154, because that's where we're using the cube model. It wasn't liking something that was happening there. Right, so now we need to spawn a new cube below. So we've done that, the BT's position. If no cube or gap there already, right, we didn't check if there was a cube there, or a gap, frankly. So yeah, we need to check that first. So we need to say if this, so we need to use our dictionary, that's right. So if this dot tdic dot get, and I'll use parentheses, let's just line this all up. equals none. So yeah, we don't want a gap. Yeah, it's just got to be none. Then we can go and do all of this. We can record the gap location, we can spawn our model, and record where we spawned it. So all of that wants to be on a new tab, so it's within the scope of this. There we go. Now that we've spawned what, if anything, we need to update subset model and finish. Done. There we go. And we're not actually looking at the BTE position. That's got to be -1. We're looking at that place below where we potentially want to spawn something. So it's only if the dictionary says, well, there's not a gap there, there's not terrain there already, then you can go. And we don't have to refer to the subdictionary, the terrain dictionary, because we're duplicating anything we record in that subdictionary here, in that case an I, we're duplicating it in our mining system's own dictionary in a bit more of a sophisticated way. We're recording the height of that terrain, and we're recording so because we're just recording the height, we're not recording I, we're not recording terrain. That, in terms of the mining system, indicates that it is some terrain, something's been built there, if it's a height, if it's a number. If it says gap, then it means it's a gap, so it can be those two things. It can be a height, a number, or it can be gap. So we want it to be Y at the moment. So yeah, we're duplicating the terrain that we're creating anyway. Yes. Okay. Right. So, let's just see if things are still working as they should. And the final thing to really do is the final key job is to, that's still working, is to, if we try and do something like that, we need to now check around this cube, and we'd say, well, just here, there wasn't any terrain, and there isn't a gap, oh no, there is a gap because I've mined below, I've mined here, but let's just say over here. Now, potentially we want to build a cave wall there. Now we don't want to do that, so we have to say, is there terrain underneath that position? Therefore, don't bother spawning a cube. If there's terrain already there, like there, don't spawn a cube, because we don't need one. Over here, there's terrain there, so we don't need to spawn one. What about over here? So through there, sorry, let's just use Ethan's scrolling. So if there isn't any terrain there, that's one thing, and there's no gap, and there isn't terrain underneath that position. So there's three things to check. Let's just go and write those down. So after we've spawned our single cube, okay, now spawn for cave wall cubes, but only so for each cube, first check whether 1, no terrain there already, 2, yeah, was no gap. Sorry, I just paused again because I had to move rooms. The lighting's pretty good up here, and the background almost looks like I've planned it, which I haven't. And hopefully the sound is okay for you. But I haven't got my mouse anymore because there's no room. I'm perched on a tiny desk. Okay. So no gaps, and then finally, what was it? No terrain below this position. Those should be, if I remember correctly, as we've just worked out, should be all the things that we have to check for. So in other words, we're just doing this again, spawning a cube, but we've got to spawn 4 of them just perpendicular around the BTE's position. In other words, now because we're doing this 4 times, we kind of need a loop, and the only thing we need to change or iterate over is the position. So we want to build up a little list where we just have 4 items on it, where we can iterate over the positions. I did that in my prepared code. Let's go and have a look at the prepared code. Here it is. Yes, now we need to spawn the surrounding cubes. There we go. Let's take all of that. Which is not on the correct level. Right, I'm using X, Y, and Z here. So X needs to be the BTE.X. Y needs to be BTE. Y and Z is the BTE. Z, just so that we don't have to obviously refer to, in fact, worse than that, this dot BTE, X, Y, and Z. So now all that code that I've just copied from my prepared stuff will work. So the first bit, we're creating 4 variables: position 1, position 2, position 3, position 4. So that's just those cubes perpendicular to the BTE position. So the potential places where we need walls, so we can't see through the terrain. And the first position is X plus 1. Oh, and the Y, we don't actually have to move. Yeah, this just wants to be the same as the BTE position. So my prepared code, I'm doing things in a different order. Anyway, so position 1, let's just have a look. So X and then the Z. Let's just go to, yes, paint.js, made by the wonderful, we have to go and have a look again, Isaiah Odner. Yeah, well done, Isaiah Odner. Let's just go to his website. There we go. Programmer and pianist. Music not shared yet. And he's got a manifesto. That's a bit scary. Coming, but there you go. Thank you, Isaiah Odner. I think I've referred to you one time before when using this paint. Okay. Let's go to. It's time for a new one. We'll discard that. So what we're doing is, let's say that's our mind position. Now this is bird's eye view, so we're looking down. Imagine we're looking down onto our terrain. We want to see if we can spawn one there, 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 and there. So if going across, I need a bigger circle there. So let's say that is our x direction, and that is our z direction. This guy, oh yeah, this guy is the B, T, E position. First we want to see if x minus 1 is available, x plus 1, and then z minus 1 and z plus 1. So that's what we're just mapping out here. So position 1 is x plus 1, position 2 is x minus 1, position 3 is z plus 1, and position 4 is minus 1. It doesn't matter what order we do these, minus and plus. I will just change that back because I'm scared. As long as they're all different. So now we've got those 4 positions, and I'm storing them as a tuple. So you see they're in brackets. They're threeple, triple if you like. They are positions in 3D space, and now I've got a spawn position list that I'm making, just temporary for this purpose, and I'm saying append to that list position 1, position 2, position 3, and position 4. So now, when we go around a little loop, we can just go around 4 times, and I can get hold of spawn position. Remember, 0, 1, 2, 3. So that will go. So I will start at 0 and go all the way up to 3. So in other words, a range of 4. Don't get mixed up with 4 being our last position, which it isn't. It's going to be 3 because we start as programmers counting from 0. So I is going to be 0 to 3, and then we want to get hold of, just like the vertices, either x, y, or z is going to be 0, 1, or 2. So x will be 0, y will be 1, and z will be 2. So we can get our spawn position within this loop. So now we just have to code it one time for each of those 4 blocks. For each of these guys, we can just basically copy this code here. And just do it once. So that's why we've done this, which is nice and simple. Okay, so firstly we need our entity. No, we don't. Well, actually, let's do that first. No, let's not. The key thing, the complicated thing, is to check whether we can actually spawn it there. That's what we want to do. But remember, for convenience, x, y, and z, or x, z, and y, are actually stored in x, z, and y variables. Yeah, I've actually got the indent block in the correct space, but not for these guys. So if so this needs to be now x, y, and z, and remember x, y, and z are going to change within this loop according to our little position system, so that we go around essentially something like 1, 2, 3, 4, or 0, 1, 2, 3, going around our loop. So for each of those in succession, x, y, and z, we want to say, where are our 3 conditions? No terrain there already. So equals none. Yeah, and so we've got to have an and condition. Oh, that covers the gap as well, doesn't it? So there's only two things I need to check, really, or I only have to do this twice. And let's go to a new line using the backslash. I need to copy that again. And we want a position below that Y position equals none as well. You can just hear my son having his nappy changed, which he doesn't like. But there we go. He is 14 years old. I mean, you know, he should be out of nappies by now. Does this make sense? So this feels different to my terrain, my prepare code. So we can ask none both times because this covers both gaps and terrain being in these positions, i.e. potential cave wall and below potential cave wall. Yes, so notice we're just adding -1 to look underneath that position, as we did when we were figuring things out. So now we can spawn. So we've checked. We found a gap such that we would look through the terrain, and the illusion's gone. So now we need to put a block there, and we can again, not from my prepare code, but from the code we've done this session, we can say, well, we want to record. No, we don't need to record a gap there, do we? We need to record, yeah, down here. Record newly spawned block on dictionary. So let's just copy that. Paste it there. So all of these bits are on the wrong indent block. Oh, I didn't quite get everything, but it included that. Okay. Oh, we're still not on the correct indent block. There we go. So entity equals cube model. So we've got the same texture coordinates as our main terrain. Build texture so we can put whatever color we want. We've shrunk it. Here's where we decide what color it is. The position needs to be this, the spawn position dot I, yeah. And it's not of this, it's just spawn position I for each of those 4. 1, 2, 3, 4, or if we're counting from 0, 0, or 0, 1, 2, and 3. We don't need to lower it. And we're not going underneath the mind area, we're going around the mind area. The parent does need to be the builds. Empty entity that we need to Ow, it's got a weird pain in my rib. We need. Hope that's not serious. We need to combine these at some point. When do we combine them? Down here. Now that we've spawned what, if anything, we need to update subset model. Not done. Also combine newly spawned blocks into the builds entity. So this dot builds combine, and yeah, that will delete those blocks. But it's okay. We've got the color is determined just like the subcubes and subsets by when we create them, like here, when we're saying its color is set there. But it's and we're using the build texture because the coordinates will be correct. But I guess the ordinary terrain texture map would work. Anyway, the important thing is that this builds entity, its texture has to be this build text. So that's monochrome and will be affected correctly by the whatever color we're kind of shining through it here. Okay, so we've done the combine. That's very good. And we've parented it correctly, and we record where it is. So that wants to be X, Y, and Z. We're not doing it around the build tool entities position. Oops. What did I just delete there? Z equals E dot Y. Yes. So that will be its position. Right. That feels like that's it. We did record, yeah, we've yet recorded news for got on dictionary. Right, so that was very, this is definitely the most complicated thing that we've done so far. I mean, we're within a class on a different module that we're importing, and we're kind of doing little tricks like the spawn position to be able to loop around those 4 positions and things like that. Record things on dictionaries and check things. Something. Oh, I was going to say something's already gone wrong, but it was because my build distance was really far away for some reason. Right. Let's try it. Okay, first of all, that looks correct, i.e. we've not spawned anything where we're not supposed to spawn anything. What about there? Oh my god, it's working. We've spawned a new, in other words, can I go to, no. I've got that one. Let's just do a load of mining. Can I go one layer down? No, I can't yet. That's the next big thing. Okay, what about just in the ground? That'd be fun. Let's go somewhere really low, about here. Fantastic, yeah. And there, brilliant. Okay, what if we build something and then try and mine it? So we can't mine things that we've already built, so we've got to sort that out. And also, presumably, yeah, we're still stepping up on where the ground used to be, so we have to reconfigure our gravity system. That's working as it should at the moment. So the illusion kind of is complete at the moment, but we need to be able to dig down. So that's pretty good so far. Let's save that. Almost, this is a very long video now, isn't it? It's 1 hour, 20 minutes. Let me just pause to collect my thoughts so I can do the next bit nice and quickly. Okay, I think I've got an idea. Because basically what we want to do, just as here we are iterating over all of the subsets, and then iterating over all the vertices within that subset, basically we want to do that again for the builds entity, where we're putting all the newly spawned cubes when we're mining, and then we want to do all of this again for that. But we don't want to repeat all of this code. We only need to do things once. So all of this stuff we want to put in its own function, which I think is fine because we're not referring to the subsets here. So yeah, in other words, if vChange equals true, then Control X to copy everything. So you want to go to this, I'll call it mine spawn. That sounds amazing. This mine spawn, that doesn't exist yet. Let's go and create that. This build, we'll do it below build tool. So we're in the mining system module, of course, and we want a new function, def mine spawn. And remember, the first keyword or first parameter has to be like dummy parameter this, or self, again if you're using better conventions. Mine spawn, and then just do all of that. I've just pasted everything in. Feels like everything is it's got way too many indents. Yeah, everything's on the wrong indent. Oh. Now, when I select loads of things and delete indents, it doesn't do anything. It just deletes everything. So I have to do all of this manually, I guess. Oh my god. Right. Yeah, so first it's seeing if we need to mine, spawn one block below dig position, question mark. So if, using the dictionary, if there's nothing -1 below where the BTE is, then go ahead. So I've got to now put all of this on the correct indentation. Again, do tell me in the comments if you are following along and actually coding all of this yourself, which obviously is the best way to learn it. But it's a lot of work. Well done. I mean, that's fantastic. But, you know, if you understand it and you just don't want to do everything, or it's just not working, then obviously you can, is that correct? Oh god, I don't want to get that wrong. Yeah, that's correct. The link in the description will take you to all of this code. So you don't have to do this. So I'm doing it for you. There you go. But if you understand it, you understand it. So that's alright. But there's nothing more satisfying. Again, do let me know in the comments. I'll be really interested. There's nothing more satisfying than doing it yourself. Now what I'm terrified of is, what if this X, Y, and Z don't lose their error correction, which they have. So that means that little squiggly red line is disappearing, meaning all these are now on the correct indentation. Oh. There's probably, I mean this is silly, there's got to be a way in VS Code to delete indents. There's got to be a way. So now, okay, so now we're in the iteration point. Yeah, we're spawning the 4 cave walls, potentially, if we need them. You know what, we don't know if this is actually working 100% because, and this, I can leave all those, they're fine. Because we haven't yet needed to generate the 4, we've only needed to generate 1 or 2. and that was working. So presumably it's well, it's indicative of being okay, but we don't know for sure. So as far as I can tell, that is on the correct line. Oh, good news! You know, when I was actually, can I find this? I forgot to explicitly mention it, but I can't remember where I've put it. Where we're using square brackets, yeah, here, we're actually just recording or creating a new dictionary key and adding a value to it. I didn't know whether we could go across different lines in Python using the square brackets. I think we've answered that question, it's correct. I keep looking over there, there's no one there. Oh, it's because it's a mirror and I'm kind of like looking at them, seeing something move and thinking it's a different person. Okay, I'm not even tired. I don't have that excuse, I'm not tired today. I hope you're feeling okay, by the way. I haven't asked. That's very discourteous of me, sorry. Hope you're okay. Right. Right, so we're in the mine function in this class, and then we said if we've changed one of the vertices, or our 36, for some reason, then go to this mine spawn, and that's where we've just done all of that. So that was scary doing all of that, so let's just see if we can get away with it. If we can, please say we can. Oh, just built something but I'm not supposed to. It looks like, oops, fantastic, it's working. So it's checking, and it knew that it wasn't supposed to spawn one there because there's some terrain below it. But we're not really testing the gaps thing because we're not mining any deeper. So that's why we've done what we just did. We created the mine spawn function so that we can, sorry, go back to the mining system module. So that in mine, oh, we can go over there. Let's delete that. We don't need to worry about deleting the hovered entity. We're using a very different algorithm now. So once we've looped over all of the vertices in all of our subsets, what we actually need to do, I do need to copy this bit again. Actually, we only need to do that. Right. Let's just put that in here just for now. After these two lines, builds, combine, and generate. Whoops. That needs to be. This needs to be there. Sorry, we only want to generate a model if we've been mining the terrain in subsets, which is vChange. So actually, we'll now, sorry, come out of there and say vChange is false, and oh, damn, I've got to come down here. Because then I've got to say oh, and we can definitely return there. Oh, what am I doing? I need to be completely out of that. I need to be here. And I'm having to concentrate as I do this. Let me just explain before I get lost. Yeah. So originally we were looping round, iterating over all of the subsets. So that's here, this like kind of like purple streak there. However, if we've noticed a vertex has changed, having gone through all of the vertices on that subset, or if we've hit 36, meaning we've mysteriously grabbed one cube, then we mine the that area and we spawn the cubes that we need. Then we generate regenerate like the terrain, so that just moves the vertices off, that actually manifests that, and then we can return, i.e. we don't need to continue with that that loop going over all the subsets, but we want to be out of that if we've gone over all of the terrain, and actually, oh no, we need to do this before. It makes sense to do this before, right? Have I grabbed everything there? Because the mines that we're creating are going to be smaller than the terrain. So we want to do this check first. So vChange equals false, and we don't want to go over the subset, we want to go over this builds. So that's the, if we've only built one block, then we're only going to check the vertices of that one block to see if we need to mine it and all the spawning stuff. So, and we haven't got like a list of builds, we've just got that one entity. And we can use like the same code. So if, yeah, so we've just copied that one test first, haven't we? So we do need to also copy that, move the vertex into the air to give the illusion of it being destroyed. Note that we've made a change, and total v equals 36 break. I'll just go vChange equals true. Put those in the right indentation. Not mystery of the 36. I need to put that down here. I'm not going to go with the 36 thing, even though it's less efficient, just because maybe the way that we've spawned these cubes, we find it won't have 36 vertices. Who knows? Maybe behind the scenes you can investigate that, maybe leave it on the issues on the GitHub. Right, and we don't need the previous make cave thingy either. So we're going over all of the vertices. Once we've gone through all of them, actually that does want to be up there, we want to say if vChange equals true. So we're on one indent down. We're going that way for you guys. One indent down. In fact, we need to be there. We need to be out of the loop. then we need to do the spawning thing. Like we've done here. Yeah, this mine spawn. Oh, we're so close now to testing it. This mine spawn, and then we want to do, oops, not assign it to true. We don't want to put true inside vchange. We'll say is vchange true. Then this builds dot combine, which we were doing before. That seemed to be fine. Okay. I think. Oh yeah. Done. Yeah. We can copy this comment tree, and again we want to return. So potentially, if we've just gone through the builds, and we've found the cube that we need to mine, then we can return. We don't have to go through the whole terrain to see if we've mined there, because we haven't. We've clearly been mining somewhere else. Okay. Maybe decide whether this is going to work. Let's have a look. Wow, we've almost gone for 100 minutes. Okay, didn't crash everything. Can we go one further? No. That is, that's devastating. So it's not letting us, so in other words, what we've just tried to do isn't registering for some reason, and we can't mine there either. Okay, let's just. But we are getting down. I've just saved the code. Let me just run that again, just in case it was something silly like I didn't save it. It almost presumes that, oh, well, of course my code works. I just didn't save it. But just in case. Let's have a little look. Yeah, it's definitely not allowing me to mine there. Hopefully it's not to do with this stuff. Assertion failed is empty or something. It's to do with models, because I don't know what's going on there. Okay, so let's just have a quick look. So, where are I? So here's the mine function in the mining system module. vchange equals false for the vertex in this build model vertices. If it's close enough to what we want to mine, then the vertex equals 9999. vchange equals true. We're not gathering the average height. That's an old comment. Let's take that out. So that's just cycling around. Then if vchange equals true, this mine spawn, and then this builds combine. Oh! Well done if you spotted the bug. Oh, this is pleasing. I think I've actually found out what it is. Actually, we should do the combine first, and then this builds model generate. Is that correct? Because we're moving the vertices like we're doing in the subsets, and we need to call generate before that change is actually visible. Model generate. Okay. The question is whether to combine. So combine. I'll do it first. Let's just trial and error for speed. And we're 3 seconds away from 100 minutes. Congratulations, 100 minutes. Hopefully, I'll be able to post this. It's going to be my biggest video yet. Sorry, biggest, longest video yet. Okay, we're still able to mine. Can I mine into the next layer? No. Oh, that was an anticlimax. And terrifying. So what's going on there? Why can't I... Can't mine there. Can't mine there. Oh no. I was sure I had the correct solution. Oh, and I was so happy, wasn't I? Okay, I definitely did save it. This builds model generate. Maybe I do it before. Let's just have a quick look at the mine spawn function. So now it's definitely working for the terrain anyway. This mine spawn, this dictionary, get the BT position, record the gap. Yeah. Okay, there's nothing that apparent. Maybe we should combine it here. So once we're spawning something, we'll say e dot sorry, this dot build combine, and we want to do that also for the single block that we're creating. And then back in the mining function, we don't need to worry about that. It's already taken care of. Oh, also, okay, so we don't need to do that here either. So we weren't combining when we're spawn. Maybe that's what was going on. Oh yes, it was. Okay, I think I found it. Because we were using mine spawn here when we're digging in the terrain to begin with, because we hadn't got any built blocks, so builds was empty. And we took the combine from here. It would be better to kind of do the combine here rather than every time we're creating a block, but it's only 4, so it shouldn't be too costly. Anyway, I kind of needed to do this inefficient way to kind of work out what was going on. Right. My God, I hope this is helpful for someone. Me debugging like this. Okay, let's... No! I was just about to say, let's make sure we haven't broken it already. What on earth? Okay, this is scary. It's kind of referring to the pandas thing. Right. Let's just we go back to, yeah, this builds combine, let's delete the combine calls there, and kind of just do it once where we need to. So maybe after we've generated, this builds combine there. So that's when we're checking through all the subsets. And then we just need to do it in when we're checking over all the vertices in the builds model itself. Fingers crossed that helps. If that doesn't work, I'll have to pause and have a look at the prepare code. I need to finish this video, it's getting so long, but I also can't leave it with a major bug like this, the basic thing not working. Okay, that's no longer breaking the code, but can we dig one layer down? Oh, thank God. So basically, something, well, I'm not sure it 100% works yet. Something like, it's looking pretty good though, something like I'm trying to delete or check that something exists, or delete something that doesn't exist yet. So I'm doing a generate before a combine, or combine before, yeah, a combine before generating it, something of that nature. Anyway, this is kind of a big moment. If it's working, we've got I was about to say we've got the illusion of as many layers as we want, but I've clearly still got a bug there. I'm somehow creating gaps where there shouldn't be gaps, and sometimes it's working correctly. So there's a little bit of a bug. Let's just keep generating some terrain. What about a hole next to it? That's pretty cool. And also we need to, so one thing is this bug up there. So I'm not quite generating them when I should be. So there's that one bug. Although, in terms of doing as many layers as we want, generally speaking, this is now working. I think the issue is just that I've got some unusual terrain patterns that I hadn't considered. Like if I do one there, that should be fine. Yep. Yep, I can delete that one. What about that one? Yep, that's fine. What about that one? So this one might go wrong. There. No, that's gone okay. So I've got to work out what was different about up here. Not sure. It might be, no, I don't know. I don't know what I've done. But it's basically looking like we've got the main mechanic working. We've got different layers. And you can probably fiddle around until my next video with the different colours and things for getting random seeds and all that kind of stuff. So the next big thing is to correct our walking terrain so we can actually fall down these holes once we've mined them. So that isn't as complicated as what we've just done. We've just accomplished something that's really quite complicated. Very well done if you followed along, and I hope you've enjoyed it. Thank you very much. I'll put all of this code up as it stands for tutorial 13 as it is, and I'll see you next time to sort this out. Thanks for watching. Goodbye.